In this video, I'll be talking about estimating sums of an infinite series. In particular, I'll talk about how many terms we need so that our estimate is within some allowable error. Here we're asked to consider the infinite series 10 over e to the n over 2. And we're asked how many terms are necessary to ensure that the sum is accurate to within 0.001. First, we need to understand that the error of a partial sum is given by r sub n, oftentimes called the remainder. That's why it's denoted with this r. And the error, there's an elegant way to show this, but I'll just kind of give you this tool. This error is going to be less than or equal to the integral from n, whatever term that is, where n represents how many terms you add this out, whether it be 5 terms or 10 terms or 100 terms. That's the n that we're looking for here. N to infinity of this formula here. So we've got 10 to the times e to the negative. What I did here is I moved this denominator up to the numerator. So we can just write it in one line there. So that's why I have the negative exponent here. And I'm also going to replace n with x here because I'm doing an integral with respect to x. So that's the process. You're taking the integral from n, the term that you're looking for, whether it be the third or the fifth or the 100th term. How many terms do you need so that you have a nice accurate estimate, and then up to infinity, and then just of the formula that you have here, replace n with x. Okay, so we're going to find now this integral. And I'll write it in green. So that is the integral from n to infinity, and that can be rewritten as the limit as a approaches infinity of the integral of n up to a of what we just have, 10 times e to the negative x over 2 dx. Now remember, this is, if you don't remember, I'll tell you, this is a way of performing an integral on an improper integral. Okay, we have infinity up there as one of the boundaries. So now we have the limit as a approaches infinity of negative 20 e to the negative x over 2 evaluated from n to a there. We're saying as a approaches infinity. So then this becomes negative 20, the limit as a approaches infinity of negative 20 e to the negative a over 2 minus a negative 20 times e to the negative n over 2. Okay, now what happens when we evaluate this limit? Well, you've got e to the negative infinity over 2. So that's like negative 20 over e to the infinity over 2. So what's happening there? The denominator is really getting huge. E to the infinity is gigantic. So this whole thing, which is this part, that just goes to 0. So we don't have to worry about that anymore. We don't have a over here anymore. We do say minus and negative, so we better say that's plus. So now we have, this was Rn in the beginning. This R sub n was less than this. This error is less than 20 times e to the negative n over 2. So now what we can say is if we find some n that is less than this error, then such that this whole thing is less than this error of 0.001, then we're okay. So if we find an n such that 20 over e to the n over 2, and what I did there is I just used properties of negative exponents to put this part back in the denominator. If we can find an n such that this quantity is less than or equal to our allowable error, that's this, then, oops, 0.001, then if we can find that, then we have the number of terms that we need. So this part, at this point, this is just some algebra. So I'm going to cut to the chase here and just tell you that n is greater than or equal to 19.8. So that means that we need at least, we have to round up here, we need at least 20 terms. Darn, that's a lot, but that's okay because it is hypothetical. I don't think we're doing this, adding this up right now, but we need at least 20 terms so that our estimate is accurate to within 0.001.